Okay, so welcome. And now in this example, we're going to do an example of finding a solid of revolution. Okay, so in this example, it says find the volume of the solid of revolution obtained by revolving the region enclosed by the graph of f of x, which is given here, and the x-axis over the interval from 0 to 1, and we're going to rotate it about the y-axis. Okay, so now, the first thing we need to do is we need to draw a picture of this thing and see what it looks like. Okay, and so, oops. So it looks something like this. Where the region we're going to be revolving is this one. Okay, and so in this case we're going to want to use the cylindrical shell method because it's going to be nice and easy to do. Because our rectangles are going to go this way, our radius, right? So we're going to use remember the formula, because we're using cylindrical shells, we're basically dealing with surface area of a cylinder. Okay, so we're going to do the circumference times the height. Okay, so in this case the height is given by h, or excuse me, f of x, and the radius of the cylinder is determined by x, the x-axis, and we just need to know the formula, right? So the formula is going to be equal to, so the volume, using the cylindrical shell method about the y-axis, is going to be the integral from 0 to 1 of 2 pi times x times f of x dx. Where this piece here, the 2 pi x, that's the distance around the cylinder, right? The rotation. And then f of x is the height of the cylinder. So this gives us the surface area of one of the shells. And then by integrating from 0 to 1, dx gives us the solid. Okay, gives us the volume. Okay, so let's do this. So this is going to give us 0 to 1. I'm going to pull the 2 pi out. This is going to be x times x squared over x squared plus 1 quantity squared dx. Which this is going to equal 2 pi times the integral from 0 to 1 of x cubed over x squared plus 1 quantity squared dx. Now, the first thing you want to do is check the degrees. So this is a degree of 3. Now be careful. Even though this is x squared, it's not a degree of 2 because we've got this power here. So this degree is actually 4. Okay? Because if you FOIL this out, the highest power is x squared squared, which is x to the 4th. So this is fine. So the degree of the top is less than the degree of the bottom, so we can proceed with partial fraction decomposition. Okay, so now, so this is the setup, so we don't need the rest of this. So let's erase this to give us some more room. Okay, so what do we get? So we've got the volume equals 2 pi from 0 to 1, x cubed over x squared plus 1 squared dx. Okay, so now the question is how do we decompose this? Now the middle here is an irreducible quadratic expression or polynomial factor. And it's a repeated factor. Okay? And then we've got x cubed in the top. So what we're going to do is we're going to set this up to using what I said before. Okay, so we're going to set this up because this is a repeated irreducible quadratic factor. So this is going to equal from 0 to 1. Oops. We're going to rewrite this as ax plus b over x squared plus 1 plus cx plus d over x squared plus 2, or x squared plus 1 squared. Okay, so now that's our setup. So now we just have to solve, okay? And we're going to equate the numerators. So we're going to get a common denominator and then equate the numerators, okay? So again, this has x squared plus 1 quantity squared, so we need another one here. Okay, so if we equate the numerators, what do we get? We're going to get a common denominator. Well, in order to get a common denominator, I need to multiply the top and bottom of this one by x squared plus 1, and then we'll be done. And then we can equate the numerators. So all I'm going to do is multiply the top here to do it. So I'm going to get x cubed equals ax plus b times x squared plus 2 plus cx plus d. Okay, now. Okay, so let's simplify this thing. Let's expand and rearrange things. So we get x cubed equals, this is going to give us ax cubed, right? And then we're going to get plus bx squared plus ax plus b. And then we have plus cx plus d. Okay, now I'm going to rearrange this and I get x cubed equals ax cubed plus bx squared, and then I get plus a plus c x and plus b plus d. Now, since I've only got an x cubed term, that means a has to equal 1, b has to equal 0, right? A plus c has to equal 0, and b plus d has to equal 0. So this is going to be nice, okay? So we know a equals 1, b equals 0. Well, a plus c equals 0, and b plus d equals 0. Well, if a equals 1, right? So if a equals 1, then that means c equals -1. And if b equals 0, that means d also has to equal 0. So d equals 0. And so now we're done because a equals 1, b equals 0, so this just becomes what? X. And what? C is -1 and d is 0, so this equals minus x. All right, so now we're done with our scratch work. And now it's just a matter of knowing how to integrate these things. Okay, so now the first one, what do you notice about the first one? The first one's going to be u substitution. Okay? So let's just do the u substitution for that one. And a u substitution for the second one too. In fact, we could do a u substitution for both of these. Oh, hold on. Don't forget your 2 pi. Okay, so let's do that. So we get 2 pi, the integral from 0 to 1. So let u, let's do this. U equals x squared plus 1. Du equals 2x dx. And again, we're going to divide by 2. And so we get what? 1/2. So, here. X, what does x equal? Oh no, we got that, yeah, we got that taken care of here, so never mind. We don't need that. So this is going to be du. So we're going to do this 2 different ways. So this is going to be yeah, we're going to do it this way. We're going to do just so we can see it more, minus, and this is going to be 0 to 1, x over x plus 1 squared dx. Okay, so now with our u substitution, this is going to be 2 pi, and this is going to be the integral from 0 to 1. Oh, let's change our limits of integration too. So when x is 0, u is 1. And when x is 1, u is 2. So we're going to go from 1 to 2. And this is going to become du over u minus the integral from 1 to 2 of du. Oh, this is 2. And this is going to be, so let's pull the 1/2 out. And this will be 1/2. And then we're going to have u squared. Okay, there we go. Okay, so now we can integrate. So I'm going to pull the 1/2 out, and so we get pi, because the 2 and the 1/2 will cancel. And we get the integral from 1 to 2. Oh, let's integrate. So this is just going to be the natural log of the absolute value of u, right? Minus, well, what does this become? Well, this is just u to the negative 2. So if you integrate that, what do? You get 1 over u. And you get the negative of that. Right? Because if you integrate this, you get u to the negative 1. You increase the power and then divide by negative 1, right? So that means we're just going to get plus 1 over u evaluated from 1 to 2, right? Okay. So let's evaluate this thing. Well, at 1, what do we get? This becomes 1, and this becomes 0. So we just get 1. Okay? At 2, so what do we do? So at 2, let's just evaluate this thing. So we get pi times, at 2 we get the natural log of the absolute value of 2 plus 1/2 minus the natural log of 1 plus 1. Well, the natural log of 1 is 0, so we just get 1 there. So we're getting minus 1. So what do we get? We get pi times what? 1/2 minus 1, which is minus 1/2. So we get the natural log of the absolute value of 2, but it's just 2, so we could just write 2. Minus 1/2. And that's the answer. So that's the volume, and this is the exact answer. Okay, have a great day.